welcome to Sandringham Building at the Leicester Royal Infirmary. Today I'm going to take you to Level 2 and Level 4 to show you how we process a sample in Fast Track. Hello, this is Level 2 Specimen Reception. This is where we receive samples internally from the LRI, from the General and from the Glenfield. We also receive samples from external hospitals and GPs. This includes Melton Mowbray, Loughborough and Hinckley. In these boxes we receive Fast Track samples in green bags and orange bags. These are then distributed or separated into routine boxes and urgent boxes. We also receive samples for special haematology, blood transfusion, histology, cytology, microbiology and manual chemistry. These are all sorted into appropriate boxes and baskets. These are then taken upstairs into the hoist and sent upstairs. In Level 2 Specimen Reception, we also receive the empty boxes so that they can be reused and refilled for later in the day. In Fast Track, we receive various different sample types. We receive urine, CSF, venous blood, and various other fluids. The venous blood can come in different monovets. The white top monovet usually contains urine. The yellow top is used for testing for glucose. The orange tops are known as lithium heparins, and these can be used to measure troponin as well as be used for other chemistry tests. The brown top is a gel which can be used for various chemistry tests. We separate this sample in the centrifuge. To analyse full blood count, we use a red top EDTA. This sample is not centrifuged and is put straight onto the Advia 2120. The green top is a citrate sample that we use to test for coagulation. It is important that this sample is filled correctly. The purple top EDTA can be used for plasma viscosity and for A1Cs.
This is specimen reception. Over here is where we do the manual forms. They're usually from outpatients. And over here is where we do the ICE forms from the GPs. And where Josh is sat is where we book them in on iLab.
For our urgent work cells, and this is urgent work cell 1. On this work cell we have a turnaround time of an hour because we receive samples from A&E through the urgent system.
This is an example of an urgent work cell. We do lots of different urgent samples here, such as paediatric samples and coagulation samples. This is an example of an urgent ICE form. We assign a different sample with different numbers. We use a barcode we place over here. We use different samples for different colours. As you can see, the red goes for the FBC, gel is the chemistry, and the coagulation is the green. This is the high-risk bench. We process a lot of high-risk samples, such as patients that are HIV positive, hepatitis positive, TB, and also COVID positive tests. As you can see, we have a different rack for different samples, such as coagulation, FBC, and any other samples. We have identified different racks for different illnesses such as COVID or hepatitis. This rack, as you can see, is just for normal high-risk samples, and this rack is for COVID positive samples. We have a separate high-risk centrifuge that we put all our high-risk samples in, so it doesn't contaminate any of the normal samples. We have these little buckets that we place over, so if there's any spillages it won't contaminate the whole centrifuge.
Once they're spun, we put them into the appropriate racks and put them on the analyzers and the track. Fast Track is the largest laboratory within blood sciences and processes more than 12,000 samples a day. It provides a comprehensive service to the hospital and community clinicians, covering both general haematology and chemistry investigations. The robotic arm then takes the samples and puts them onto the track. This is where chemistry samples are decapped.
This station is mission control. This is where we look after the track and all the analyzers attached to the track. So from here we can take analyzers offline. Also we can see what tests are available and take any tests offline that we don't need. We also do the sample validation for any samples that have abnormal results.
The gates on the track scan the barcode on the sample to direct it to the appropriate analyzer for testing.
This is the StarMax 2 coagulation analyzer, which measures clotting screen. It is used to diagnose and monitor coagulation abnormalities. A coagulation profile consists of PT, APTT, thrombin time, fibrinogen, and D-dimers. PT helps evaluate how quickly your body forms a clot. INR is calculated from PT and is used for monitoring patients on warfarin. So to measure the coagulation screen, we use a green top sample which has an anticoagulant called citrate. And the method principle that the analyzer uses is viscosity-based detection. So this is the cuvette with a ball inside. This ball oscillates from left to right. When the viscosity of the sample stops the ball from moving, the clot is formed and we have a clotting time.
The Avia 2120, which is an amazing analyzer that does our full blood count tests. You might wonder how we get through all those tests in a day, but this machine can actually throughput, when it's in its automated mode, it can throughput 120 samples in an hour. We can, as well as using it automated with the samples coming off the track, we can put through samples manually. So I'm going to demonstrate that now. So inside this wonderful machine we've got a system of syringes, reagents, and chambers where the whole blood that I'm going to introduce from the patient's sample gets mixed with reagents, and through flow cytometry and colorimetry we get results. So I'll demonstrate that to you. I'm going to put this through manually and have a look and watch it go through, because it goes quite quickly. So the sample's divided up by this valve here and goes into the various areas, various chambers, mixed with the various reagents. And then we can get results very quickly onto our screen. This is not just one test. This gives us, the full blood count gives us the number of white cells, but it also divides those white cells up into the different sorts of white cells, the ones that eat and fight infection, the ones that help us with our immunity, and others as well. It also gives us our red blood cell count, how many red blood cells have we got, and what is the haemoglobin concentration. The haemoglobin that carries oxygen around the body, it gives us that result as well. It also tells us about how many platelets we've got, and what sizes they are. So this machine is one test, but actually gives us many, many results that we can help to look at diagnosis and treatment with patients.
Blood films are made to aid the diagnosis and management of hematological disorders. You can make blood films from whole blood from EDTA or citrate samples. In a good film, there is a thick portion and a thin portion, with a gradual transition from one to the other. If a full blood count or coagulation sample produces spurious results, we check it for a clot, because if the sample has clotted, then the platelet and white blood cell results will be incorrect.
This is the Benson viscometer. The Benson viscometer measures the viscosity of plasma in the sample. Plasma is the straw-coloured fluid you can see in this sample here. This sample has been spun down. The samples we use are 2.7ml EDTA samples, which are either the grey or the purple top samples. The samples move around the carousel till they get to this part here. This is a probe that goes down into the sample. In this cassette here, we have a small capillary tube with two sensors. The thicker the plasma, the longer it will take to get between the two sensors. The thinner the plasma, the quicker it will be between the two sensors. PVs are important for conditions such as temporal arteritis, giant cell arteritis, headaches, myeloma, and in children, septic arthritis.
That's through the infirmary. We use human centroid species to analyse the immunoassay test. So this machine uses chemiluminescence technique. This includes the sandwich and the computed assay to measure the test. So the immunoassay tests we do in these machines are thyroid functions like PSHs, BP4s, tumor markers such as CA125, CEAs, CA199, and so on. And also we do some fertility hormones such as LH, FSHs, testosterone, prolactin and progesterone. We also do cardiac markers such as BNP and troponin. In future we are thinking of doing the COVID antibodies in this machine as well.
The chemistry analyzers can take aliquots from the specimen straight from the track.
This is our XPT analyzer. It's quite a flexible analyzer and can be used to analyze things such as serum and plasma, but also CSF and other fluids. There's two main methods of analysis. You've got your ion selective electrodes. These use electrodes to measure the potential of a sample and can give you the concentration of things such as potassium and sodium. And in the main body of the analyzer you have your general chemistry tests. These work by spectrophotometry, which generally is just colour change in the reaction, and that can help you identify the amount of what you're testing for.
So this is the Abbott Architect. We use it for immunoassay, where we do troponin for heart attack, and we use a lithium PET sample, and we use it for COVAD, which is the antibody for COVID, and we use a gel sample. So currently we've ran over 26,000 samples of the COVID antibody. We're measuring the long-term antibody, which is the IgG. We've only had an 8% positive.
When analysis is complete, the robotic arm then takes the samples from the track and puts them into unloading racks. Caps are then placed on the chemistry samples by the recapper so that the samples are ready for storage.
This is the cold room. This is where we keep our chemistry and haematology reagents that have to be kept in cold temperature. We also keep our chemistry and haematology samples. Some chemistry samples are kept for a minimum of 3 days and haematology are kept for 2 days.
So I hope you enjoyed our little video and found it really informative. I hope to see you all soon.